All right, today we're going to talk about implicit differentiation. Suppose you were asked to find the slope of the tangent line to the curve x squared plus y squared equals 25 at the point 4, 3. So, first of all, not solve for y, so we're going to solve it for y. So, subtract the x squared, and then do your square root. So, one thing you want to think about is at the point 4, 3. So, this right here is a circle. So, at the point 4, 3, that slope is negative. So really you would want the negative radical 25 minus x squared, okay, because of the specific point we're at 4, 3. So we have y equals negative square root of 25 minus x squared. Now we take the derivative. So taking the derivative, dy dx equals derivative of the inside is negative 2x. Derivative of the outside. Now remember, this is 25 minus x squared to the 1/2. So we're going to have negative 1/2. So negative 1/2 times 25 minus x squared to the negative 1/2. The 2's cancel. Negative times a negative is a positive. So we have x over square root of 25 minus x squared. So now, when we find the derivative, that's your derivative. So specifically, the slope of the tangent line at the point 4, 3, we plug in 4, 3, x is 4, and 25 minus 4 squared, that's 16, that's 9, square root of 9 is 3. So that gives you 4/3, and I need to go back. When we put in that square root, it is plus or minus. Okay, so plus or minus means that could be plus or minus. And now we decide at the point 4, 3, that's a negative slope, so it is the negative answer we're looking for. So, negative 4/3. Oh, I did that step early. Okay, so negative 4/3 is our slope of the tangent line. Now, that is called explicit differentiation. That means we can solve for y and then take the derivative. Now, can we do that with this problem? Can we solve for y? Y cubed and y, not really. So we're going to go back and talk about implicit differentiation. When we cannot solve for y, it's difficult or it's impossible to solve for y. We need to use what's called implicit, and that allows us to take the derivative without isolating one variable. And what's going to happen if you have something like x plus y equals 4, that derivative, well, the derivative of x is 1. The derivative of y, if you recall here, when we do the derivative of y, that is dy dx. Okay, so plus dy dx equals the derivative of 4 is 0. And then you just solve for dy dx, that is negative 1, which if you had solved for y equals 4 minus x, dy dx, then derivative of 4 is 0, derivative of negative x is negative 1. Okay, so that works there. So when we do implicit, x squared plus y squared equals 25, you do your derivative of x just normal, that's 2x. Do your derivative of y using the same rules, except whenever you do the derivative of y, you have dy dx. And that is saying, okay, the derivative of, that's kind of a chain rule, the derivative of y is dy dx times the derivative of the outside, that's your 2y. Okay, so it is using the chain rule. Derivative of 25 is 0 minus the 2x and then divide by 2y. The 2's cancel, so you get dy dx equals negative x over y. Okay, that is using implicit. So let's do some more examples. So this one, x squared minus y squared equals 16. The derivative of x is 2x minus the derivative of y squared. Well, the derivative of the inside of the y is dy dx. Derivative of the outside is your 2y. Derivative of 16 is 0. So here, minus the 2x and divide by negative 2y. So you have dy dx equals your 2's cancel, the negatives cancel, x over y. So at the point 5, negative 3, dy dx equals 5 over negative 3. Okay. Example 2. This right here is a product. All right, so yes, we use the product rule just like we use the chain rule. So here, when we're using the product, derivative of the first is 1 times the second plus the first derivative of y is dy dx plus the derivative of y is dy dx equals derivative of 8, which is 0. Okay, so this right here is your product rule. Derivative of y is dy dx, derivative of 8 is 0. Okay, now we need to isolate the dy dx. So we're going to subtract y. So now you have x dy dx plus dy dx equals negative y. You're going to factor out the dy dx. You're left with x plus 1. And then divide by x plus 1. So dy dx equals negative y divided by x plus 1. At the point 2, 3, now we plug that in. So your derivative equals negative 3 over 2 plus 1. That's negative 3 over 3, which is negative 1. So your slope there is negative 1. Okay, hopefully this is making sense, but we'll do some more examples. Oh boy, this one, we have 2 product rules. That's a product, that's a product. All right, starting at the first. Derivative of x squared is 2x times the second, so times y, plus the first, which is x squared, times derivative of y, which is dy dx. That is the product rule for the first one. Plus the product rule here. Derivative of x is 1 times the second, which is y squared, plus the first, derivative of the second, derivative of y is dy dx, and then derivative of the outside is 2y. So this is the product rule there, equals derivative of 2x is 2. So we need to, let's see, minus the 2xy over to this side and minus the y squared over to this side. So here we have x squared dy dx plus this is 2xy dy dx equals 2 minus 2xy minus y squared. Factor out the dy dx on the left. That's x squared plus 2xy equals on the right 2 minus 2xy minus y squared. And then divide by x squared plus 2xy. And that's your derivative. Okay, a little messy, I know, but that's how you do it. So derivative at the point 1, 1 is 2 minus 1 over 1 plus 2. So that's negative 1/3 is your derivative. All right. Let's keep going. Another example. So example 4. This one, lots of y's in here, so we'll have lots of dx. So y cubed, derivative of the inside of the y is dy dx. Derivative of the outside is 3y squared. Plus y squared, derivative of the inside is dy dx. Derivative of the outside is 2y. Minus 5y, derivative of 5y is 5 dy dx. It's really another derivative of the inside is 5, so or y, so that's dy dx, and the derivative of 5y is 5. Minus the derivative of x squared is 2x, and the derivative of negative 4 is 0. So we need to add the 2x over. Here, factor out your dy dx. You're left with 3y squared plus 2y minus 5, and then divide. So dy dx, that was supposed to be an arrow, equals 2x divided by 3y squared plus 2y minus 5. So there is that one. Alright, I'm going to do a couple more that involve trig. So dy dx is 4y equals x squared minus cosine of x. So you have to find dy dx. Derivative of 4y before dy dx. Again, the chain rule. Derivative of y is dy dx. Derivative of 4y is 4. Derivative of x squared is 2x. Derivative of cosine is negative sign, so minus the negative will be plus sign. All you have to do is divide by 4. So 2x plus sine of x divided by 4. All right, next we have this one, second derivative. Okay, so let's first find the first derivative. Derivative of x squared is 2x. Derivative of y squared, derivative of y is dy dx. Derivative of y squared is 2y. Derivative of 16 is 0. And then you need to minus the 2x. Basically minus the 2x and divide by 2y. So you get dy dx equals negative x over y. So now, let's start up here. Dy dx equals negative x over y. So your second derivative, d squared y over dx squared. This is a quotient. So the derivative of the top is negative 1 times the bottom minus the top. It's a negative x, so it becomes plus x. Derivative of the bottom is dy dx all over the bottom squared. Now, this dy dx can't stay there. What does dy dx equal? Negative x over y. So you just need to plug that in. You have negative y plus x times negative x over y all over y squared. You then need to, can't leave a fraction within a fraction, so we're going to multiply everything times y. Right? So that gives you the derivative equals negative y squared, the y's cancel, minus x squared all over y cubed. Okay? Now, I will tell you this. If you get this answer on a multiple choice, what could happen is you can factor out a negative 1 on the top to have y squared plus x squared all over y cubed. And if you look back at the problem, x squared plus y squared equals 16. So that answer would be negative 1 times 16, or negative 16 over y cubed. And that is your second derivative. Okay? That's how it would be given to you. So you just want to be careful. You can make all the, that you do make all the substitutions that you can. All right. Let's see. I think there was one more I wanted to do. We did that one. This one right here. That's going to be similar to what we just did. This one, example 8. This right here, we have to use a chain rule. All right. So this one, the derivative of the inside is 1. Derivative of x is 1 plus derivative of y is dy dx. You have derivative of the inside times the derivative of the outside, which is 2 times x plus y. So you've got to multiply those. Plus derivative of y is dy dx equals derivative of 2 is 0. So what happens here, this is basically the distributive property. Okay, you have this whole thing times 1 and the whole thing times dy dx. That gives you 2 times x plus y plus 2 times x plus y dy dx plus the dy dx equals 0. Subtract this one over. So you have, and I'm going to factor dy dx out of here. So dy dx, and what's left is 2 times x plus y plus 1 equals negative 2 times x plus y. So to finish that out, you have negative 2 times x plus y divided by 2 times x plus y plus 1. And it is fine to leave it like that. Looks a little messy, but it's fine. All right, so I think that is enough examples for you to go out and try some on your own now. So there are some examples, some practice out of the book that I wanted you to do, page 146, the first homework there for implicit. Right?